So our topic, designing secure cloud architectures for financial services on AWS PaaS. Our project is titled Designing Secure Cloud Architectures for Financial Services on AWS PaaS. It focuses on securing cloud-based financial workloads by applying best practices from AWS, NIST, PCI, DSS, and APRA CPS 234. The architecture is built around the cloud security lifecycle: plan, build, deploy, and monitor, ensuring continuous protection and compliance. Our team is divided into 4 key security domains. I have worked on identity and access management using IAM and Cognito. Thrushil handled data protection and encryption with KMS, S3, and RDS. Rushil implemented network and application security using VPC, WAF, and CloudFront. And Deepjyoti Mili covered monitoring, compliance, and governance using CloudTrail, GuardDuty, and Security Hub. Together, these 4 layers creates a secure, auditable, and resilient cloud foundations for financial services on AWS. Next up, this is my architecture that shows how we secure identity and access in AWS. It is split into 2 layers. The top one is the admin plane and the application plane. On the admin side, IAM enforces multi-factor authentication, strong password policies, and least privilege access through a deny without multi-factor authentication guardrail. All admin actions are logged in CloudTrails, stored in the versions S3 buckets, and monitored with CloudWatch. On the other side, the Amazon Cognito manages the customer authentication with multi-factor authentication and issues JWT tokens that the app validates before accessing AWS services like S3 or RDS. Combined with TLS and KMS encryptions, this design delivers a zero trust, fully auditable, and compliant identity framework for financial services on AWS. I'll start by showing you how to enforce a strong password policy for all the users in the AWS account. Here I have set up the minimum length to 12 characters, requiring uppercase, lowercase, numbers, and symbols. The password will expire every 90 days. This ensures users maintain strong, regularly updated passwords, protecting the account from the brute force and credential stuffing. Next up is I will be creating the least privilege user group, which I've named as Finance Lab users. This group only has access to specific AWS services required for the task, ensuring least privilege access. I have also attached a multi-factor guardrail, which ensures that sensitive action cannot be performed unless multi-factor authentication is enabled. This adds an extra layer of security to protect against unauthorized access. Next is provision user with console access. So I've created a test user called FinStudent with console access. And the user will have an auto-generated password and can log in using the provided URL. This ensures that only authorized users can access the environment. So next, I have created an app client. Once again. So I've created an app client named User Pool. User Pool EXOEIJ for secure authentication with web applications. We have set the access token to expire after 60 minutes and refresh tokens after 5 days. This token expiration settings help manage user sessions securely, ensuring that users must authenticate after a specified period. So for the conclusion, we have successfully set up IAM for secure access and multi-factor authentication. We also created a Cognito We also created a Cognito user pool to manage user authentication, including multi-factor authentication, strong password policies, and session management through the app client. By implementing IAM and Cognito, we have significantly enhanced the security of our cloud environment, ensuring that only authorized users can access sensitive resources. Thank you.
Hello everyone, I am Durshil Shah, and in this video I will demonstrate how I implemented data protection and encryption in Amazon Web Services. I'll be showing 4 key security controls in the AWS console. First, Key Management Service. Second, Amazon S3, the server-side encryption using Key Management Service. Third, Amazon Relational Database Service encryption at rest and transport security enforcement. Fourth, Amazon Backup Vault using Key Management Service. This is my architectural diagram. Please have a look. Let us head to console. So as we can see, we got key management service, S3, the RDS, and the AWS backup. Let us start with key management service first. The first control in Amazon Web Service is the key management service, where I created a custom master key, which is also called CMK. Our CMK is our KMS is finance prod KMS. This is a symmetric encryption key which is used to encrypt and decrypt sensitive data. So as we can see, it is a symmetric key. It's also used to do the encryption and decryption. As we see here, the key is fully controlled by our AWS account under our own security policies. I have also enabled automatic key rotation, which replaces the cryptographic material yearly to maintain strongly encryption hygiene. This meets the strict enterprise and finance compliance requirements for centralized key management. Now let us head to S3 bucket. So for S3 bucket, we have got finance prod secure logs. So as we can see that in under properties section, we got the default encryption section. We can see that the server-side encryption with Amazon Web Services is enabled. So here it is. That means every object uploaded to this bucket is automatically encrypted at the rest using our own custom master key, even if the user forgets to apply encryption during upload. This ensures that the financial or personal data cannot be accessed in the plain text. Let us head to the next section, which is the Aurora and RDS. So this is my Amazon Relational Database Service. As shown here, let me head to the databases first. So our database is FinProd DB1. So as shown here, the storage encryption is enabled. As shown here, storage encryption is enabled. So here it is. And encryption is also enabled. So as this encrypts the database storage logs and automated backups. Let me head to parameter groups. So for parameter group, to secure data in transit, I applied a customer database parameter group where the setting is require setting transport is equals to 1. That ensures all the database connection must use the transport layer security, which encrypts communication between client and database. This prevents the attackers from intercepting or reading sensitive data while it travels over a network. So let us head back to the last one, that is the AWS backup. So doing the AWS backup, as we can see, we got multiple backups. So let me head to the vaults. So as going to the vaults, we got a vault that is FinProd vault. As we can see clearly, it uses a key management service master key and for encryption under recovery points. We can clearly see that we can see multiple completed backup jobs. This confirms that the backup data is strongly protected at the rest and cannot be restored without proper authorization. Even if a backup is stolen or copied, the attacker cannot decrypt it. So to conclude, this implementation shows a complete security approach for protecting sensitive financial data. Encryption at rest using key management service and customer master key, encryption in transit using transport layer security, and secured encrypted backup using AWS backup.
Hi everyone, I'm Rushil and my part focuses on network and application security. The main goal of my implementation was to design a secure AWS network that isolates resources, limits unnecessary exposure, and protects our application layer from common attacks. I use services like VPC, security groups, EC2 to demonstrate how multiple layers of defense come together in real cloud setup. This is the architecture overview, and I'm going to explain you the architecture. This is the two-tier secure architecture I built at the foundation. We have a VPC with siren notation 10.0.0.0/16, which are divided into public and private subnets. The public subnet handle the web tier and connect to the internet through an internet gateway, while the private subnet stays isolated for backend services. I then created a security group that allows HTTP port 80 from anywhere so the web page is reachable, but SSH is locked down only to my IP. This ensures nobody else can log in or modify the instance. Finally, the web tier and EC2 instance running NGINX sits in the public subnet in a production setup. Uh, so yeah, so now I'm gonna explain you on the console. Let me share my console. Here you can see my VPC named group 123 with its siren notation 10.0.0/16. This is the isolated environment that defines our private network boundary. Now I'm going to show you the subnets. These are my public and private subnets. These are my public and private subnets linked to the route table that sends all the internet bound traffic 0.0.0/0 through the internet gateway, while the private subnet stays disconnected. I'm going to show you the routing table now. As you can see, subnet association public, two public subnets. Then I also configured security group for the inbound rules for group 1 to 3. As you can see, here's the security group. I configured HTTP open for web traffic and SSH restricted to my system's IP. This rule designs keep attackers on random users from brute forcing the instance. Now I'm going to show you the EC2's instance. As you can see, the instance is up and running. This is my EC2 instance named Web Nginx. I used a user data script that automatically installed and starts Nginx when the server boots, so it's ready to serve a web page immediately. And now I'm gonna show you the final proof. This way. So, yeah. And here's the final proof. When I open the instance public IP in a browser, you can see the network and app security demo page. This confirms the routing, gateway, and firewall configuration all work together exactly as planned.
Hi, my name is Millie, and I have implemented monitoring and governance using AWS config. So this is the architecture of what I have implemented. So this architecture shows monitoring and compliance using AWS config. CloudTrail captures all the API and user activity and store logs in an encrypted versioned S3 bucket, and AWS record shows configuration changes in real time, snapshots in the same bucket. I added config rules uh, to check CloudTrail, S3, and KMS compliance. The config dashboard shows real-time compliance and change history, ensuring continuous visibility and governance across our AWS environment. First, I created a S3 bucket, group 123 audit logs div1, where permissions, public permissions are blocked and versioning enabled, and SS3 encryption for compliance. Next, I created a CloudTrail named Group 123 Trail 1 to log both management and data events with validation enabled. This ensures every API call is tracked and protected from tampering, meeting PCI DSS and NIST audit requirements. Then to verify, I downloaded a JSON file which I have stored in Notepad. And here, if we check, we can, it clearly shows event time and event source, event name, etc. So these logs are immutable and encrypted, making them suitable for forensic and compliance use. Finally, I have created a dashboard. So I configured this AWS config for continuous monitoring and compliance monitoring. It records all the resource configuration changes in real time and stores snapshots in the same audit bucket using its service-linked IAM role. I also implemented config rules. I implemented these rules to verify CloudTrail is enabled, S3 buckets are not public, and KMS key rotation is active. So this dashboard shows real-time compliance and change history, providing visibility and accountability across the cloud environment. Thank you.